Okay, to round up the day, I'd like to look at a couple of questions from a review 6.1 just to get you going in the right direction. The first three I'm not going to really look at because they're just all versions of this review, just review 6.1. So the first three are all just different plug and plays of current is equal to charge and divided by, or change in charge divided by time. So they're all just plug and play versions of that. Let's look at number 4, which says that the drift speed of electrons in a copper wire running from a battery to a light bulb and back is approximately 0.020 millimeters per second. Battery is at the front of the classroom and wires run around the perimeter of the room to the light bulb. Total length of the wire is 40 meters. How long would it take for a single electron to drift from the negative terminal of the battery back to the positive terminal? And express your answer in days. So you know right away it's going to take a while. So what do we know? We know that the drift velocity is equal to 0.020 millimeters per second. Now that's not a lot. In order to do any of this, again, you have to translate into meters per second. So this, another way of writing that, millimeters is 10 to the minus 3. So you could write it like this: meters per second. I know this is not in standard notation, but so far as the calculator is concerned, as soon as you plug it in, it's going to recalibrate that anyway. And the length, we know, is 40.0 meters. Well, velocity is equal to distance divided by time, right? So time, therefore, is equal to distance divided by velocity, and in this case it's just the drift velocity, which is equal to 40 meters divided by 0.020 times 10 to the minus 3 meters per second. And when you calculate that out, this comes out to 2.0 times 10 to the 6 seconds. So all you have to do now is just to translate that into days. And so it turns out that there, in 1 hour, there's 3,600 seconds, and there's 24 hours to a day. So seconds will cancel, hours will cancel, and you're going to have your answer in days, and that comes out to 23 days. Now notice that there's only 2 significant figures there, and that's because the speed is only 2 significant figures here. Yeah, this is 3, but this is 2. Okay, so 23 days is fine. Alright, so that's that one. Why don't we do, what do we look at? No, number 5, you can use your QR code. I was going to do that with you, but you can use your QR code to do that one if you're stuck. I suggest you give it a shot, but whatever. Let's look at number 6. How much silver is deposited by a current of 1.000 amps in 1.00 hours? The mass of 1 mole of silver atoms is 107.9 grams, and you're given the half reaction there. Which is a 1-to-1 ratio. So what do we know? Well, let's write this down here. 6 current I is equal to 1.000 amps. Time is equal to, what did they say? 1 hour, which is equal to 3600 seconds. So the reason that we change that into seconds is because you will recall, where is it, that current, this is just an aside, this is an aside if you like, just thinking out loud, aside, is that 1 amp is equal to 6.24 times 10 to the 18th electrons, right, per second. So what we want to do is we want to figure out how many electrons in, what did they say, 1 hour? 1 hour. So 1 hour, 1.000 hours to be exact, or 1.00 amps times 6.24 times 10 to the 18 electrons per second times 1 hour is 3,600 seconds is equal to 2.25 times 10 to the 22nd electrons. Okay, now the reason why they put this is to so you can make the assumption that for every electron of every one of these electrons that it flows, 1 atom of silver can be made. So what this implies that 2.25 times 10 to the 22nd electrons is equal to 2.25 times 10 to the 22nd atoms. Okay? Okay, well, we know if we've got this many atoms, we know that's part of a mole. And so how much part of a mole? Well, it's 2.25 times 10 to the 22nd atoms times 1 mole is equal to 6.02 times 10 to the 23 atoms times, we can run this all together, 107.9 grams per mole, because up to this point, this times this is going to give us moles. So I can multiply it by the atomic weight, and this will give us 4.0 grams. Moles cancel, atoms cancel, and you've got grams. Okay? So carry on. You've only got, what I did 2, you got 6 left. 2 of them have QR codes, so you're in the pink. Okay, we'll see you next day.